Good morning, everyone. Today we will going to discuss about first programming in 8086 processor in Unit 1. We have three different programs in 8086. Now I will share my screen. This is your syllabus for microcontrollers and interfacing. Because subject code is 18 ECC 311G. The first program in your syllabus is Lab 1 program to demonstrate data transfer operation and logical operation. Data transfer means transferring the data from one register to another register, and logical operation means and or a not operation. So we will see how to implement these operations in 8086 simulator and how to check the outputs. So now to do this program, we prefer open source software like 8086. Software we used for this is EMU8086. Now I tell how to download the software, how to install it. Go to the Google search bar. To Google and search EMU8086. Download. So you will, it's a emulator. I told I emulator, you know very well, is converting the assembly language code into a machine language code. The code which will be executed by microprocessor. Microprocessor will capture only the machine level code. In order to convert the assembly language code into a machine level code, we need a emulator. The emulator we prefer here is EMU8086. Download the software and install it. It is open source. So after downloading, you will get that set on your desktop. So EMU8086 is a software emulator. We plan to implement programs for 8086. So open the software. This will show one window with the different option: file, edit, bookmarks, assembler, emulator, math, ASCII codes, help. First, go to the file and create a new project. New. Simply click new. This will open your new project. Click OK. You will get it. I just select all the unwanted things. Now, first I will tell how to write basic syntax for 8086 programming. I already created one basic syntax for 8086. How to write, how to start program, how to end the program. So I hope you know data will be stored in the data segment, and code will be and instructions will be stored in the code segment. So in data segment, you will need to define the input variables. For example, if you want to add two 8-bit number means you will need to define the value for A, value for B, and output as sum and carry. So this For example, A will hold some data, 16-bit data, like that way. Similarly, B, it will get some data. So all the data details will be, you must need to give inside the data segment. So if you start data segments means you need to end the segment with data space ends. This is the way how to define data segments. Start with data segment and end with data space ends. Similarly, for code segment, you will need to define code segment. We need to end with the code ends. Similarly, for data segment, data ends, code segment, code ends. So inside the code segment, we will need to assume space cs colon code ds colon code. So all this program will be decoded by assembler. So assembler will decode the instruction and convert it into machine learning language. So in order to get data from the segments, you will use ts as this shortcut name. So if you want to access code segment means you just simply use CS as the code. This will help. This will help assemblers to convert the instructions from one language to another language. So for example, assembler. So we are writing the code in assembly language. So if you want to convert the assembly language into a machine code, we use assembler. So assembler will assume CS as code segment and DS as data segments. By making use of these two different keywords, we can able to access data segments and code segments in programming. Similarly, if you want to start writing instruction means you will need to begin with the start colon. After that, after writing all the instruction, you will need to end with end start. This will inform you that the program will end. Program is going to end in this line. Similarly, I already told an interrupt 21H video section um, video file. So if you want to terminate your program, you will need to use these three set of lines. Already explained in the while discussing the INT21 interrupt concepts. So if you want to how to terminate the program, if you want to end the program, terminate the program, you will need to mention move AH comma 4CH, move AL comma 00H. INT21H. If you assign 43 to AH and 00 to AN register, this will inform interrupt 21 to do some function. What it will do, this will inform the microprocessor to terminate the program. So before see here. Before code segment gets sent, you will need to write this set of codes before the code segments ends. So you will need to write move AH comma 4CH, move AL comma 00H, INT21. This will help you to terminate the program because otherwise the program will start executing and it will execute indefinite number of times. If you want to terminate the program to stop, you will need to use these three different instructions to terminate the program. So these are all the default codes we mainly used by software engineers, system engineers to terminate the program. Just go through these three different statements to to terminate the program. So now we will see the first program in 8086 about the program to demonstrate data transfer operation and logical operations. I already created one example file. Just make use of this. Just use this file and practice similar type of programs while writing the experiment number one. So I have the code for data transfer. This program is mainly used for transferring data and for do some logical operations. I already told we have data segment, data ends. We have the code segment. Um, we have the code ends. So if you want to write instructions one by one, you will need to start with the keyword called start colon. So after writing all the instruction, you will need to terminate with end start. These are all the basics. Similarly, if you want to terminate the program, you will need to use three different lines. I've already told in the previous video. If you want to terminate the program, you we need to use these three different lines. Move AH comma 4CH, move AL comma 00H, INT 21. So AL takes 4C, AL takes 00. Now, if you assign this value to AH and AL, this will inform enter 21 to terminate the program. These are all the basic syntax in 8086 programming. Um, Okay, now we will see how to assign data inside data segment, how to define instructions inside code segment. Now, I hope you know already, data segment will store data, code segment will store instructions. This program is mainly used to transfer the data from one register to another register, and how to exchange data, how to perform logical operations like AND or all these things. First, I define one variable with a and type. It may be a data word, it may be data byte. So here I defined how many bit for a. It's a one variable. It will store some data. Data may be 8 bit or 16 bit. So if you define a value for a as 16 bit means 1, 2, 3, 4. Totally we have 16 bits. So if you convert 1, 2, 3, 4 in binary form means you will get 16 binary numbers. So it is a 16-bit number. So we store this number in data word. Data word means 16-bit. So we define the variable type, how many bits you want to store. That will be defined with this type of the variable. Then value for the variable a. Similarly for b, another number with value 3210h. It is also a type of data word because it contains 16-bit binary data. If you convert this four number into binary form, you will get 16-bit binary value. So only it will store 16-bit value. So I mentioned it as a data word. So C also a 16-bit value. So I mentioned it as data word. So if you add two 16-bit numbers, you will get output as one a 16-bit number. So I define VAX, VBX, VCX, VAA, VA0, VAP, VBP, VCP are all the output variables. So after adding and after transferring data, you must need to store that value with different output variables. For that, I defined different name for different operations. I will see what value will be stored in VX, VPX, VCX, VWA, VAO, VAP, VPP, VCP. So I initially assigned it as a garbage value. Garbage means undefined. So when you will get the output, so after executing the instruction only, you will get the output value in the this variables. That's why I mentioned it as a question mark. That is a garbage value, empty value. So the value will be assigned to all the variables after executing all these instructions in the code segment. So data ends. So if you start with data segment means you will need to end with data ends. Similarly, if you start code segment means you will need to end with code ends. Similarly, assume CS colon code, DS colon data. So this will assume assembler. So this is a assembler. This software is a 8386 assembler. This will convert all this instruction from assembly language to machine learning language. So if you want to decode each instructions one by one, decoding is converting. If you want to convert assembly language program to machine learning language, you will need to access each and every instruction. If you want to access instruction, you will need to go to code segment. For that, I define CS colon code segment, DS colon data segment. If you want to access data segments, means if you call DS means this will go directly to the data segment and access the data from each variables. So I start writing the instructions. First instruction is for move AX comma data, move DS comma AX. Now see what it means. Okay, in the instruction I write, there is move ax comma data and move ds comma ax. This means we have the initially the value for data here is initially the value for data here is 00h. So this value will be assigned to data. One second. So what you write below the code segment, assume cs colon code and ds colon data. Okay, ds colon data means if you call ax comma data means this will access the data segments memory. It will access all the data available in the data segments. So if you call move ax comma data means this will point out all the data stored inside the data segment and assign it to the register ax. Then ax move ds comma ax means AX will access a offset address in data access a offset address in data segment. This will access all the locations available in the data segment. It will access each and every locations one by one. So if you want to access these locations means by simply informing AX register, we can able to move any of the offset addresses and we can able to get the data out of the data segment. That thing will be done by AX register. That is the meaning for AX. AX will point out the all the offset address located in data segments. If you define this two differently, the meaning here is AX is a register which will point out all the offset address available in the data segments. So if you want to access this data means we can by making use of this AX we can able to access data A. If you want a data B means by making use of this AX register we can able to get data from data segments. The meaning here is it will simply point out all the memory address locations in data segment. By simply accessing AX we can able to access any other locations by simply calling the offset addresses. So for move AX comma data. So when you that means decoding this instruction, assembler will automatically assigns the offset address of data segment. That offset address will be stored in the AX register. Now the AX value is the offset address of data segment. That thing will be pointed by the data segments. So AX always point out offset address in the data segments. If you want to access any of the locations in data segments by simply calling the AX register, you can able to get any of the data from data segments to perform some operations. That is the meaning for this concepts. Thing here is first here is data. If you use move AX comma data means data will hold the offset address of data segment. The offset address will be moved to AX register. AX register will point out all the offset address, that means memory locations in data segment. DS means data segments. If you want to access any of the data in data segment by simply calling the AX register, we can able to get data from data segments. Similarly, move AX comma A, move BX comma B, move CX comma C. So, what is the meaning for move ax comma b? Data present inside the variable. What is the value we present inside the variable a 1 2 3 4? That data will be moved to ax register. It will simply copies the value present inside the a to the ax register. So AX is a 16-bit register. It can able to hold the value from variable A. Similarly, if you want to transfer the data from variable B to the BX register, it will simply copies the values present inside the variable B. Value present inside the B here is 3210. It is a 16-bit number. This will simply copies and move to the register BX. Similarly, move CX comma C means this will simply copies the 16-bit number stored inside the variable. What is the value stored inside the variable C? Or 010123. This will simply copies the values for C in the CX register. Now we will need to display the values stored. That means transferred from A to AX, B to BX, C to CX. You want to display these variables. So I assigned the output variables VAX, VBX, VCX. These are all the variables which will show you the outputs. What data is available inside AX, BX, CX. If you use move VAX, comma AX, this will simply copies the values present inside AX to the. This will simply assigns the value for AX to VAX. Similarly, if you use move BBX, comma BBX, means this will simply copies the value assigned to BX to BBX. Similarly, move BCX, comma CX, means this also done the same operation. It will simply copies the value stored in CX register to the VCX. This will simply copies assign this value to the VCX output variable. Next, and AX, comma BX. Now we will see what is the operation for and OR. These are all the logical operators. It will perform logical functions. We will see what and logical operator will perform and OR operation will perform. Now first refer what is the value for A and what is the value for B. The value for A here is 1 2 3 4. Value for B here is 3 2 1 0. Okay. First, we will see what is the basic truth table for AND gate. AND means, for example, if you have two variables and one output variable, assign the value for A and B, 0, 0, 0, 1, 1, 0, 1, 1. What is the value if you perform AND operation? AND means simply it will shows multiplication. If you add 0 with the 0, the output is 0. If you add 0 and 1, you will get output as 0. 1 multiplied with the 0, the output is 0. If you add 1 with the 1, the output is 1. Just simply multiplying the two different variables, A with the B, similarly. So if you multiply the any number, 0 and 1 with zeros, the output will be zeros. So if you multiply any number with the ones, multiply, and if you add any number with the 1, the output will be simply the same, 0 and 1. So, now we will see the operations for AND instruction, and AX, comma BX. So what is the value for AX? AX equal to 1 2 3 4 H. Similarly, what is the value for BX? 0, I think 3210 H. Just a minute, I will check. Value for A here is 1 2 3 4. Value for B here is 3210. Right. Now we will going to perform AND operation. First, convert the 16-bit number assigned to AX into binary form. A here is 1, 2, 3, 4. Convert that number into binary form. What you will get? 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 0. Similarly for bx, value here is 3, 2, 1, 0. Binary equivalent here is 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0. So if you add these two values, performing and ax comma bx, the operation performed here is it will add ax with bx and store the result in ax register. See what is the output? 0 and 0, 0. See the truth table 0, 0, 0. Similarly, um, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0. This is the AND operation results. Convert this binary number into equivalent hexadecimal form. If you want to convert the binary number into hexadecimal form, we need to do 4 digits. 4 digits. What is the binary? What is the hexadecimal? What is the equivalent number here? 0, 0, 0, 0 means 0. 0, 0, 0, 1 means 1. 0, 0, 1, 0 means 2. This one is 0, 0, 0, 1 means 1. This is the hexadecimal result after performing AND operation. This is the result after performing AND operation. So the result will be stored in the AX register. We will see how to do that. See the program and AX comma BX. After performing AND operation, the result will be stored in the AX register. If you write move VAA comma AX means the value after performing AND operation stored inside the register AX will be assigned to the output variable VAA. That means value after addition. It may be any name. So your user defined value. VAA equal to AX. The value assigned after performing addition operation will be stored in the variable VAA. Similarly for OR, AX comma BX. This will simply perform the OR operation. Now we will see how to perform OR operation here. Value for AX is 1, 2, 3, 4, H. Similarly for BX is 3, 2, 1, 0, H. Now, if you perform OR AX comma BX means this will simply perform OR operation. What is the logical truth table for OR? 0, 0, 0, 1, 1, 0, 1, 1. This is A, this is B, this is C. OR means simply adding 2 bits. 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. This is the truth table for OR gate. Now we will perform the addition or operation for with AX with the BX. What it will do here is simply it will performs OR operation and store the result in AX register. And the value for AX Here is 1, 2, 3, 4. Convert this into binary form. 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0. Similarly, for dx, 3, 2, 1, 0. Binary equivalent is 1, 1, 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0. So after performing OR operation, that means AX comma BX, we will get the result as 0 plus 0 is 0, 0 plus 0 0, 1 plus 0 1, 0 plus 0 0, 1 plus 1 0, carry 1, 1 plus 1 0, carry 1, 1 0, 0, 1 plus 1 0, carry 1, 1 0, 1 plus 1 0, carry 1, 1 plus 1 0, carry 1, 1 0. This is the output results. Group 4 bits and you will get the results. So, 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 so this is the value. This is the operations of our OR operation. And what is the next instruction? So after performing OR operation, I just store the result from AX to the output variable VA0. This will simply copies the value for result after performing OR operation to the VAO register, VAO output variable. Next, what operation I am doing here is exchange. Exchange, you know very well what is exchange. Yeah, I just exchanging the exchanging the value of lower nibble value to higher nibble value, or higher nibble value to lower nibble value. You will say what is exchange, how it's performed. New slideshow. Now we will see what exchange operation will do. What exchange instruction will do. Exchange XCSG AL comma AH exchange BL comma BH exchange CL comma CH. Um, we assigned the value for we have the value for AX, BX, CX. We already have value for all the um, registers. Initially, we assigned what? Move AX comma A, move BX comma B, BX comma B. These are all the instruction we defined initially. Move CX comma C. What it did, value for A will be moved to AX register, value for B will be moved to BX register, value of C will be moved to CX register. Now the value for AX we define the value we assigned for A here is value for A here is A equal to 1, 2, 3, 4 H. Value for B here is 3, 2, 1, 0 H. Similarly for C here is 0, 1, 2, 3 H. So after performing this operation, move AX comma A, move BX comma B, move CX comma C, the value of for A will be assigned to AX, value for B will be assigned to BX, C will be moved to CX. Now the value for AX here is 1, 2, 3, 4. So it will simply copies the value for A to the AX register. Similarly, BX means this will simply copies the value for B to the BX register. Value here is 3210H. Similarly, CX, this will simply copies the value for C to the CX register. Value here is 0, 1, 2, 3. Here in this case, which one is higher level, which one is lower level. The lower digit is a lower level, lower lower byte. This one is a higher byte. This one is lower byte. This one is higher byte. Similarly for CX, this one is lower byte. This one is higher byte. What exchange instruction will do here is this will simply copies the lower byte value to the higher byte this higher byte and register and higher byte register value to the lower byte register. This will simply uh, transfers or copies the value for lower byte to higher byte to lower byte. You will see now what is the value for um, now, after performing the exchange operation, this will simply copies the value for AX to AL and AL to AH. So, after performing the exchange operation, the value for AX now here is 3412H. Similarly, for BX here is 1032H. Similarly, for CX, value here is 2301H. What it means here is the value for C34 will be moved to higher byte, 12 will be moved to lower byte. Similarly, lower byte will be moved to higher byte, 32 will be moved to lower byte. Similarly, 43 will be moved to higher byte, 01 will be moved to lower byte. This is the operation for exchange instruction. This will simply copies the higher byte to lower byte to higher byte. This is the operation for exchange. So after performing exchange operation, now we will see the what is the output for after exchange. Nothing will be possible through this simulator. The exchange AL, AH, BL, BH, CH, CL, CH. This will simply copies the lower byte to higher byte to lower byte. So after that, we do move VAP, AX, VPP, BX, PCP, CX. After exchange, value will be altered. That altered data will be stored in the register variable output variable VAP. For BX, it will be stored in the VBP. After exchange, value for CX will be stored in the VCP register, VCP output variable. This is the code. I already know this. This is used for terminate the program. This will inform the microprocessor to stop the operation, and then code ends, code start. Now the programming is over. It's time to check the outputs. In order to check the outputs, go to the emulate. Just click it. So this will shows one window with run option. Just click run. A program has returned control to the operating system. It means there is no error in the program. So after clicking OK, just go to the base VARS. Just click it. You will get the output value. So value for A here is 1234, B here is 3210, C here is 0123. This is the output window. Where now the value for VAX here is 1234. What is the instruction? This will simply copies the value for AX to VAX. So this will copies. Similarly, for after performing addition, the value here is 1210. Similarly, your value after our operation is 3210. Then VAP means after exchanging. After exchanging. Similarly, VBP after exchanging. Similarly, for VCP after exchanging, this is the output value. This is the outputs. By simply checking the values, we can able to tell what operation it performs. I hope you understand the program for faster programs in your syllabus. What is the program? Program to demonstrate data transfer operation and logical operation. Just use this program and prepare a lab manual for experiment 1 and finish it. Just install the software and try this code. Here is the code. Just type this programs in your software and check for outputs. This is the procedure. Type this code, and after that, click emulate. So just click run. You will get no error message. After that, click variables. You will get the output window. Check the output values for all the output variables. Now the job is done. Just try these programs in EMU8086 emulators and do the first experiments in microcontroller interfacing program. This is the first program, how to transfer data, how to perform logical operation. I hope you understand how to do that. Just refer the video and complete the first experiment.